Okay, folks, we're going to finish off chapter 17 with a little run through of exact calculations. A lot of this is going to be looking at surds from chapter 13, so you might want to have those notes handy. So essentially, an exact value is anything which can be like a fraction or a number or a root or a constant or anything that isn't just like a rounded decimal. The idea is that it is exact and completely accurate. And it's a really important facet of non-calculator maths, being able to manipulate stuff in this way. I would say that most of the things you know from surds and from algebra will apply here. You've just got to apply them. So let's look at these as examples. We want to find the simplified exact value of these expressions. So if we've got brackets, the first thing we should do with those is multiply them out. That's going to give us 4 pi plus 8. And here we're times it by minus 3. So we're going to get minus 3 pi plus 3, because we're doing a minus 3 times minus 1 there. We would then want to try and simplify things together. So we have got a 4 pi here, and we've got a minus 3 pi here. And if we put those two things together, we'll just get 1 pi, or just pi. We've got a plus 8 here. We've got a plus 3 here. That will go overall to plus 11. And that's all you've got to do. So expand any brackets and then collect terms together. We wouldn't be able to do anything with that, and we shouldn't stick it in a calculator and get like 14.16. That's our exact answer. Similar idea here, we've got double brackets this time, so we're going to have to use the claw. So that will give us 2 pi squared minus 2 pi plus 3 pi minus 3. We can then simplify this middle bit together. We've got minus 2 plus 3 pi, so that will go to 2 pi squared plus pi minus 2 plus 3 is 1, minus 3. And that's it. Again, we don't want to combine together pi squared and pi. Those are different things, and we don't want to sub anything in. And then the last one. Now, if we've got a bracket with a square by it, that means that the bracket happens twice. So we should first write that out as being 3 pi plus 2 times 3 pi plus 2. We can then do the same as what we did on the previous question and claw multiply it together. So we've got 9 pi squared from there, 6 pi from there, 6 pi from there, and 4 from there, and then combine those two middle terms together, 9 pi squared plus 12 pi plus 4. So exact values, just same as algebra, multiply, expand, simplify, collect your terms together. Now, the most common use of this in GCSE is going to be things involving surds. So if we talk about surds, we're talking about square roots of things. Here's a reminder of the rules that we looked at last time we did surds in chapter 13. We've got a multiplication rule, a division rule, and just a general root times a root gives the number itself. So for example, I mean, if you did root 3 times root 4, what you would get would be 3 times 4 inside there, so 12. If you did root 9 divided by root 2, you would end up with the square root of 9 over 2. And if you did root 7 times the square root of 7, then you would get yourself 7. So they're fairly self-explanatory. I want to remind you of a couple of bits and pieces that we were able to use with surds, because we're going to need to use them in this chapter as well. So let's look at the first one we've got is fully simplifying. Now, fully simplifying with surds generally means we need to split them up a little bit while still keeping them exact. So we take our root 20 and we want to split that 20 into two numbers where one of them can actually be square rooted. It'd be useful to think about your square numbers at this point. So we've got 1, 4, 9, 16, 25, etc. Which one of those divides into 20? Well, just 4 divides into 20. So we're going to split this into a square root of 4 times the square root of 5. This is using rule 1. Now, the square root of 4 is 2, and square root of 5 doesn't have an answer, so we just leave it as the square root of 5, and that's all you need to do. Okay? Second example, we have to do the same thing again, this time with a couple of different numbers. So we'll look at 27. We'll say, well, 9 goes into that, so I can split this into root 9 and root 3. 54, I think the only thing that will go in there is 9 again. That'll be a 9 and a 6. And then 48, you can fit 4 in there, but you can actually fit 16 in there as well. And we generally want to pull out the largest square root that we can. So we're going to take out 16. So we've split up our surds into squares and remainders, and then we want to try and figure them out. So we've got square root of 9 here, that's just 3. So we'd write this as 3 root 3. We've got the square root of 9 here, so that would be 3, and it's 3 root 6. And we've got the square root of 16 here, which is 4, so we'd end up with 4 root 3. Now if we're looking to fully simplify this, we can only combine together things which have the same power, or same surd. So we've got 3 root 3, take away 4 root 3, that's overall going to give you minus, or minus 1, lots of root 3. And then we've still got this plus 3 root 6. We can't combine these together, they are different surds. That's a root 3 and that's a root 6. So that's fully simplified, that's as far as we can go. Lastly, we still need to do the same thing here. We've got root 12. Now again, think about a square number that would go in there. I think 4 will go into 12, so we'll use that. So this is 4 times the square root of 4 times the square root of 3. We can split up that 12 there. And then we're not going to bother splitting up root 4 because we know it's 2. So we could write, instead of 6 root 4, we can just write 6 times 2. Then we can think about this first one again. We've got 4 times the square root of 4, which is 2, times the square root of 3. And then we've still got our 6 times 2 over here. And we can finally simplify this all together. 4 times 2, so that's 8 root 3 plus 12. Again, we can't combine our surds, our root 3s, with our numbers, so that's fully simplified. We can obviously do the same thing with brackets. We can expand them. We can see what comes up with. So let's do that. We're going to do 3 root 2 from the 3 times the root 2. And then that'll be minus 18 from the 3 times the 6. And it'll be plus 3 pi from the 3 times the pi. And you can't do anything with that. Pi is a constant. Root 2 is a surd. 18 is a number. We can't combine anything there, so that's as simple as it gets. Let's look at a slightly more complicated one. Root 2 times 4, that's just 4 root 2. We generally put the number at the front. And then root 2 times root 2 is just 2. So 4 root 2 take away 2, that's as far as we can go. For the third one, we're going to get 5 times 5 is 25. We're going to get 5 times root 3, so that'll be minus 5 root 3. We're going to have plus 5 root 7. And we're going to have, so if we times 2 surds together, we can use that first multiplication rule. We can go 7 times 3 inside the root is 21. And can we do anything with that? Well, we can't combine together 25 with anything because that's a number. We can't split up 3 into any square numbers, or 7. Or 21. So yeah, that is actually fully simplified. You can't do anything with that. That would be our final answer. So let's look at one which you actually will be able to simplify once you expand. So here, we're going to use our multiplication rule. We've still got 3. We're going to times our square roots together. So 2 times 8 is going to give us 16. And then for our second one, we're just going to take away 3 root 6. Now remember, the square root of 16 does exist. It's 4. So we can just write that in, and we can't split up 6 into anything, so we're just going to leave it as a 6. And that will give us overall 12 take 3 root 6, and that is fully simplified. And the last little surd thing that we looked at was this idea of rationalizing. Now rationalizing means that we want to make the bottom of our fraction into a whole number. So the denominator needs to be whole. And the way that we do this is we multiply the top and the bottom of our fraction by a surd that will help cancel stuff out. Now, in the case of this first one, because we've got a root 7 on the bottom, we're just going to times the top and the bottom of that by root 7. On the top of our fraction, we'll end up with 3 root 7. On the bottom, well, root 7 times root 7 is just 7. That's rule 3, I think we looked at on the surds. Have we made the whole denominator into a whole number? Yes, we have, so that's done. Second one. We could times the top and the bottom by 2 root 3, but we don't need to. You only need to times by the surd that's on the bottom. So we're just going to times the top and bottom by root 3. So the top of this will end up with 5, and then root 2 times root 3 is root 6. On the bottom, we'll end up with 2, and then root 3 times root 3 is 3. We can simplify that a little bit. We can say we've got 5 root 6 on the top, 2 times 3 is 6 on the bottom, and then that's as far as that will go. Denominator is a whole number, so we're sorted. Next one, we're going to multiply by root 5 in this case. And because we've got 2 terms on the top, we have to treat that like it's a little bit of a bracket. So let's maybe write that out before we expand it. We've got square root of 5 times 3 plus root 2 on the top, and we've got square root of 5 times the square root of 5 on the base. Remember, all the way with fractions, you times the top by the top and the bottom by the bottom. We could then expand this, so we'd end up with 3 root 5, and then root 5 times root 2 times the surds together, root 10. On the bottom, root 5 times root 5 is just 5, and then we just need to think, can we simplify anything here? Well, root 5 doesn't split up into a square number, root 10 doesn't split up into a square number, so that's done. Alright, 2 more to look at, and these are probably the trickiest bits of surds. If you've got 2 separate terms on the bottom, so here we had one term that just happened to have a number in it, but here we've got a 3 plus a root 5, then we need to times the top and the bottom of that by what we call the conjugate of that term, which just means the same thing but with the plus replaced with a minus. So we need to work out this whole fraction times 3 minus root 5 in this case. So again, let's do top times the bottom, top and bottom times the bottom. So we've got 4 lots of 3 minus root 5, and we've got 3 plus root 5 over 3 minus root 5. Let's expand our brackets. So the first one on top will give us 12 minus 4 root 5. And then the base, we're going to have to be careful here that we don't have too many lines. We've got 3 times 3 is 9, minus 3 root 5, plus 3 root 5, and then minus 5. Now the really clever thing about this method is that you end up with a minus 3 root 5 here and a plus 3 root 5 here, and those two cancel out entirely. They just go to 0, so you can ignore them and you can just think about having 9 minus 5 on the base. So we've got 12 minus 4 root 5 over 9 minus 5, which is 4, and then you can actually simplify this even more because both of these terms, the 12 and the 4 root 5, could be divided by 4. 12 divided by 4 would be 3, and 4 root 5 over 4 would just be root 5. So that is our final simplified answer. You might want to pause at this point and try the last one for yourself, but let's get straight into it. We're going to times this by 6 plus root 2 on this occasion. Again, remember we are taking whatever sign is on the bottom of our fraction and we're changing it. So there's a minus this time, we swap it for a plus. This actually means that we're going to have to do expansion on the top and the bottom. So we're going to have to expand on the top. We've got 2 times 6, so that's 12. 2 times root 2, so that's 2 root 2. Root 3 times 6, so that's 6 root 3, and root 3 times root 2. And again, remember, if you've got a surd times a surd, it just stays inside the surd. 3 times 2 is 6, so root 3 times root 2 is root 6. Then do the same for the bottom. We could use the shortcut, but we're not going to on this example. 6 times 6 is 36, plus 6 root 2, minus 6 root 2, and then what haven't we times? We haven't times root 2 by root 2. So that'll give us a minus 2 at the end. So let's get rid of all those lines now. So we end up with this interesting collection of surds. We then want to try and simplify what we can. Now if you look at the top, we've got a 12, which is a number. We've got a root 2, we've got a root 3, and we've got a root 6, and we cannot add those together. They cannot be simplified. So the top of our fraction is just going to stay exactly the same. At the bottom of our fraction, we know that the 6 root 2 and the minus 6 root 2 are going to cancel out. So we're just going to have 36 minus 2, so that is 34 on the base. And then you think, well, can I divide top and bottom by anything here? Well, not really. I can divide 12 and 2 and 6 by 2 and 34, but I can't divide root 6 by 2. I can't split up root 2 or root 3 or root 6. So there's nothing more to do with that. That's fully simplified. Okay. Now, just to finish off this little topic, we're going to try and apply this to some shape questions. And obviously there's a lot more we can do with this. We can bring in all the volume and surface area stuff that we looked at in chapter 14, I think it was. But we're not going to do that now. We're just going to use some basic 2D equations. So let's look through. First question we've got a square with a side of 3 plus root 2. I'm just going to draw that because I think that'll help in terms of explaining / understanding. And it says we need to find its area and its perimeter. Now let's do the area first. The area of a square is base times height. The base is 3 plus root 2 and the height is 3 plus root 2. If we multiply those two together, we're going to do another sort of clause situation. So we've got 9 plus 3 root 2 plus 3 root 2 plus 2. That goes to overall 11 from the 9 plus the 2 and 6 root 2. And then because it's area, it's centimeters squared, and that's all you do. You can't simplify that anymore. For the perimeter, that means adding up all of the sides of the shape. Now, all of the sides are going to be the same. They're all going to be 3 plus root 2. So we could do 3 plus root 2 plus 3 plus root 2, etc., etc. However, it might be more sensible to just times it by 4, because we know they're all the same. 4 times 3 is 12. 4 times root 2 is 4 root 2. Units are centimeters. So that's all we can do. Okay, slightly trickier question here. We've got to find the area of a trapezium. Now, for a trapezium, the formula is a plus b over 2 times the height, where a and b are the two parallel sides of the trapezium, and our height is obviously the height of the trapezium. So let's put those into that formula. We need to do a plus b, so 5 root 3 plus 3 root 3 over 2, and we're going to times that by the height, which is 2 plus root 3. So let's look at the top here. We've got 5 root 3 plus 3 root 3, that goes to 8 root 3, which we want to times by 2 plus root 3. 8 divided by 2 is 4, so we've got to 4 root 3 times 2 plus root 3, and then we can expand our bracket, so we'll end up with 8 root 3 from the 4 root 3 times 2, and then for the other term we'll have 4 times, well, root 3 times root 3 is 3. Simplify that a little bit more. 8 root 3 plus 12, units are centimeters squared, and that's as simple as we can make it. Okay, last two questions. Again, you might want to pause and have a go first, but I'm just going to crack on. We've got a circle of radius 10 and it's got an area. So the area of a circle is pi r squared, and area of a square of side x, so it's base times height, which if they're both x will be x squared. So they've got the same area. So we can say from the start that pi r squared is equal to x squared. Now it says we want to find the exact value of x, and the only thing we know here is the radius of the circle. So we can go ahead and say pi times 10 squared is equal to x squared. Now 10 squared is 100, so we can go to 100 times pi is equal to x squared. And if we want to get the answer past there, we're going to need to square root. So we'll say that we are the square root of 100 pi. Now that is sort of exact, but we can simplify it a little bit. We can split 100 pi using again that first rule of surds into root 100 times the root of pi. Square root of 100 is 10, and the square root of pi is going to be some horrible number, so we just leave it in exact form. Centimeters was the unit, so x will be in centimeters as well. Okay, and the last question, and this is probably the trickiest one I can think of. We've got a rectangle with an area of 14, and again we know area of a rectangle is base times height, and it's got a base of 3 plus root 2, and we need to find its height. So what we're saying is something times that 3 plus root 2, so h times the 3 plus root 2, base times the height, is equal to 14. Now, how would you do that? Well, if we want to get h on its own, we need to divide across by the 3 plus root 2, and then what we've got is a rationalizing question. Now, what do we need to do with a rationalizing question? We need to multiply in the top and the bottom, changing the sign from being a plus to a minus, so we're going to times it by 3 minus root 2 over 3 minus root 2. Now, If we expand that out, we're going to do 14 times 3, so that's 42. 14 times root 2, so that's minus 14 root 2. And then on the base, we'll end up with 3 times 3 is 9, minus 3 root 2, plus 3 root 2, minus 2. Remember, if you've done it correctly, these two terms will always cancel out. So that will give us on the top 42 minus 14 root 2. And on the bottom, just 9 minus 2, which is just 7. Now you can simplify that again. Both of these numbers, 42 and 14, can be divided by 7, so we'll do that. And we'll say that overall we've got 6 minus 2 root 2, and it was in centimetres. And that is our exact value for the height of the rectangle.